morning, everyone. I got a little visitor. This is my puppy. His name is Marcel. Say hi, Marcel. Say hi. Yeah. So in this video, we are going to talk about Chapter 4, Software and Systems. Our agenda for today is to summarize the characteristics and components of information systems, identify technologies used by startup and small businesses, explain how growing businesses enhance their systems, and describe the features of an implementation consideration of an enterprise resource planning system. Now let's discuss how systems capture and process data. If you recall from our previous classes, an AIS, or Accounting Information System, is a type of information system that focuses specifically on executing and capturing data generated by business events. Online systems that perform real-time activities can be classified as either being online transaction processing systems or online analytics systems. Online transaction systems just support core business functions by handling sales, accounting, purchases, and more. So they just capture the business events, whereas our online analytic processing systems focus on leveraging the data for information. So these systems use the data that are captured by online systems and further analyze it so that managers can use that data as information to guide decision making. So remember, systems capture data, and through analysis we create information, and this information can then be further used for decision making. Okay. Here is a nice table summarizing the difference between OLTP and OLAP, or OLTAP or OLAP. When we ask the following questions, such as what are online transaction processing systems just process transactions. They capture business events, whereas our online analytic processing systems process this data and summarize it into information through reports and other analytics. How is this data captured? As transactions roll in, each transaction modifies the database by adding and changing the transaction data. Whereas with our online processing systems, we use queries to abstract data to answer questions. We're going to talk about databases in a further chapter, but remember that queries are used to retrieve data from databases and then analyze it into information. When do these events occur with our online transaction processing? This is occurring in real time, and the same thing with our online analytic processing. So these are both real-time systems. The one is, however, the online transaction processing system just processes transactions, whereas our analytical system creates reports and analytics. As we discussed in class, different employees require different information. So there are different information systems used based on who the user is. So our executive support system supports strategic decision making, and they are a subset of decision support systems, whereas our decision support system assists in solving non-routine problems and unstructured decision making. So these are systems that are utilized to answer specific questions that are not typically a daily function of the business. Then we have our management information systems, or MIS, and these assist in routine management activities, and AIS can be considered part of the MIS. And then we have our transaction processing systems that we just discussed in the previous slides. And these process day-to-day business activities, providing a foundation for other systems and capturing data that is fed through the levels. So if you think of it as a hierarchy, what you're going to have is the transaction processing system feeding all these other systems, and your DIS also feeds your ESS. Here is a nice summary in the textbook of the levels of our information systems. So we start off with our transaction processing system that's used by workers, and it's just used for capturing data. And an example is workers like cashiers use your transaction processing system for basic business operations. Many of these basic business activities result in accounting transactions. Then we have our management information systems that are used by our middle management, and they're used for routine business decisions. So your planning, your reporting would be done by your MIS. And these systems use data from the transaction processing systems to support structured, tactical, and operational decision-making by providing pre-specified historic reports through the transaction processing system, such as routine summary reports and exception reports. Financial statements are summary reports. Then we have our decision support systems, and these are used by upper level management for non-routine decisions. So these systems report both internal data and external data. They can model data, do simulations, and perform what-if analysis. They can use AI to perform tasks normally requiring human intelligence, and the reporting format will be suitable for making specific decisions at a specific point in time. So these are your non-routine decisions, such as should we purchase our competitor? Should we expand our product line? You would do those types of analysis and answer those questions with decision support systems. And then executive support systems are used for strategic decisions, and these systems provide customized information and have a small group of users that are executives. Let's talk in further detail about transaction processing. Modern day transaction processing systems collect data continuously in real time for day-to-day business activities. They generate business process documents such as payslips, customer orders, invoices, and receipts. And then these documents are each a type of internal control specific to the business process that creates them. So make sure that you remember all those controls we talked about in previous chapters, and all the risks we talked about that controls address will need to be integrated into your transaction processing system. And modern transaction processing systems include our OLTP systems, and these are process-based, and they capture all data of interest to the company. Because our transaction processing system collects data as it is created, it's important to ensure that the system is always available, so there's no outages or crashes, and that the data recorded is correct so that you have data integrity. And there's two types of ways that transaction processing systems can process data. That is either using batch processing or real-time processing, and we'll get into that more in the next slide. Now let's talk about batch processing. Batch processing occurs when data is collected as it is generated and then is processed later at a scheduled time. So for example, with let's say we have a grocery store. all the daily transactions are collected, and then you have just one upload into the database at the end of the day. So what occurs in this type of system, we have the business event. So business event occurs and transactions are collected and organized into a batch. This batch creates a file, and this file is updated with additional transactions, and at a scheduled time we have the batch updating the database. So for example, end of day, like I said. Now let's discuss the benefits of batch processing. One of those benefits is efficiency. Because you are processing many transactions at the same time, you can achieve economies of scale. Also, there is simplicity in the system because once you have a schedule, it makes things less complex. In terms of quality of data, fewer errors will occur as the data flows through the pre-established steps and schedule, which is an important benefit. The other option for processing data is real-time processing. And in this type of a system, a transaction is processed immediately once it occurs. This requires a company to have high processing capabilities because there's constant transactions occurring. And the benefit of real-time processing is that you have current and updated accounting records at all times. You don't have to wait for a batch to occur to get the newest information. You can retrieve the data right away and you will have all the information you need. And in this type of system, you have a business event occurring, and those transactions are processed as the event occurs, and your database is immediately updated. Now let's talk about software. Please remember that our information systems are comprised of numerous parts, and those parts include hardware, software, databases, and networks. And when we discuss software in this course, we're talking about the interface between the components and the users, so individuals, employees. And software govern how other components work with one another, and they provide users with a means of interacting with the system. And software is always created using programming language. And programming language is a set of code instructions that the system understands. And there's many programming languages out there. They include JavaScript, Java, HTML, Python, C++, C++, Go, and Scala. If you have time, it's a definite benefit to learn a programming language. This is a highly sought after skill. It is something I wish I knew even from my research perspective, because in my research I run experiments, and those experiments are run on a computer that I have to pay programmers to program, so I wish I could program myself. But software are items such as our Word documents, our various apps, etc. Now let's talk about a specific type of software, system software. And system software is specialized software that runs a computer's hardware and other software. It's a platform for other software that coordinates all activities throughout the system. Operating systems support a computer's basic functions such as task management, executing applications, starting up and shutting down. And two widely used operating systems are Microsoft Windows and Apple Mac OS. So if you have a computer, your computer will likely use either Microsoft or Apple Mac OS. Let's talk about different types of software. We have data management systems, and this is software used to define, manipulate, retrieve, and manage data in a database. And this includes MySQL, SQL Server, Oracle, or Microsoft Access. When I worked at Canadian Tire, I worked there as a senior business analyst many, many years ago. And we use Microsoft Access to retrieve data. I was in charge of analyzing all of the point of sales merchandise, so the things you see at the cash register and how they were selling. So I would retrieve information from Microsoft Access regarding how our stores were performing, and I would retrieve different tables, different columns to figure out performance. We didn't have any standardized reports. We created all our reports for the category managers that we were assisting. So I've used Access many times and it really brings me back to a different way, but most places now use either MySQL or Oracle. Then there's data communication software, and this software is used to provide remote access to exchange data between computers and users. So this is messaging and email software, which I believe we all use every day. Then you also have the file transfer protocol FTP client. Then we have our utility programs, and this is software used for analyzing, configuring, optimizing, and maintaining a computer. So these are things such as Network Manager, and I'm sure we all press Alt Control Delete. Everyone always laughs when they look at my computer how many files and different programs I have open. So I use Network Manager all the time to close down files if my computer's running too slowly. We have our antivirus software to protect us from various cyber attacks and viruses. Backup software, in case there's errors, you can retrieve your information. Disk cleaners, and we also have file compression software. If the files we generate are too large, we can compress them. Perhaps the software that we all use the most is application software, also known as an app, and it's an end user program that performs specific functions. Application software is designed for general use and can be purchased readily through digital downloads, and every app that you have on your phone is an example of application software, and it can be custom developed for specific functions, or you can just purchase various apps or download some for free. When it comes to software sourcing, organizations face a decision on how to acquire software. They can either purchase it from a third-party vendor, or alternatively, they can develop the software from scratch using in-house development. Now let's discuss some risks related to purchasing third-party software. Companies always have to be cognizant of copyright infringement. So if a business isn't adhering to software licensing policies of the vendor, the business could face legal allegation and reputation loss. So it's always important to read those copyright agreements. I know we are all guilty of clicking I accept, because they're all in legal jargon, like teeny tiny font, maybe like 8 or 6 even, and like pages and pages long. But it is important to ensure that you're using software properly. You always have to be wary of any data breaches. So you need to find a trustworthy vendor and ensure that the company made software that is not vulnerable to hackers or malicious programs. So make sure that there are firewalls and various security features built in. Then you always have to be cognizant of disruptions. What would happen if that third-party vendor closes? Would that result in your business operations completely being disrupted? You have to make sure that in those events in the contract, there's a way of accessing the source code so that your business can continue. And then you always have to be wary of updates, because software is purchased and oftentimes vendors will create updates just to generate more revenue. So you have to ensure that the vendor doesn't have an excuse to bill additional hours, and that customers have an option to refuse rather than being forced to utilize all these updates and features. There are also risks associated with developing software in-house, and this includes budgeting. So it's very important that the company employs the necessary talent to write the code and maintain the system. And this can be expensive, especially for small organizations that don't have a large IT department and do not have programmers on their payroll. Then you always have to be cognizant of scheduling, because software may take longer to create than expected. When I was working at Vale, I was part of an enterprise ERP system. And what we found was that the system schedule originally was a year, and 2 years later, it was still in development because a lot of the processes and functions and features needed to be realigned for us, and there wasn't enough planning in the beginning phases. So those are risks, that the schedule might be blown, and something that you expect will take a very little time might take a very long time. Then you have to think about the technical specifications. You have to ensure that the software is properly developed and reflects the business processes that it's trying to capture. Then you also have to look at an external market. If you're in a fast-paced industry, there's a risk that by the time the software is developed and implemented, the industry and market changes will cause the software to require updates. So maybe your business processes change drastically, or there's new technology that makes the technology that you developed obsolete. And there's always a risk of fraud. You can have software programmers find ways to circumvent fraud controls. There might be some backdoor that allows unauthorized users, or allows the programmers to grant unapproved permission to users. So it is important to have your system audited to make sure that there are formal controls within the system, and those controls can't be circumvented. Now let's discuss cloud computing. We are going to learn more about cloud computing later on in this course from one of our groups that is doing their presentation, but we're just going to briefly touch on it in this chapter. Cloud computing allows businesses and individuals to rent memory or storage space from providers and use them on demand instead of buying or owning them. Your files are stored in a cloud, which is a network of servers that can be accessed through the internet. When I was doing my PhD and I was working on my summer paper, my computer crashed. And at that time, I wasn't using any cloud systems. All of the information was on my computer. And I was working on a research paper that I spent months and months researching, doing literature reviews, collecting data, creating various instruments, etc. And all of a sudden, I lost everything. I still remember the tears. It was ugly. It was really sad. And since then, I've been using Dropbox, and I am a huge proponent of Dropbox because all my files are on the cloud. So if something occurs on my computer, I'm still able to retrieve all my files. So for the definition of cloud computing, it provides accesses to shared resources over the internet, such as computer processing, software application, data storage, and other services. Cloud computing allows companies to minimize computer resources being kept on hand. So in a lot of ways, it can minimize risks and costs because companies don't need to purchase so much physical hardware and servers. There are 3 ways that cloud systems can be deployed. You can have a private cloud, and this is exclusive for one business, and it's maintained on a private network. Hardware and software will be always dedicated solely to that one business. The advantage of this is that it's customizable and provides high security. The disadvantage is that it is costly. It's the most costly out of these options. On the other end of the spectrum, we have a public cloud, and this is available to the public through a provider such as Dropbox. If an organization uses a public cloud, it will still be secure, but users access these services through a web browser. The benefits, it's readily available, and the costs are much, much lower. Then in the middle of kind of these 2 options, we have our hybrid cloud, and this is a mixture between private and public cloud with a divider between the 2. In this environment, the data and applications can move between the 2 environments, the public and private. The benefits of it are that it's increased flexibility, moderate cost, and moderate risk. Now let's discuss cloud computing service models. We have the SaaS, or software as servers, and this utilizes the internet to provide access to customers with applications that are managed by a third-party provider. This software leverages the provider's data storage and IT infrastructure, and examples of this are Google Drive, Salesforce, Slack, Microsoft Office 360, and Tableau Server. Then we have Platform as a Service, or PaaS, and this provides customers a platform for software development delivered remotely. Developers have access to maintain operating systems, servers, storage, and networks, and the focus is on designing and building of application software. And examples of this are the Google App Engine, OpenShift, Apache, and Stratus. And then we have infrastructure as a service, and here we provide customers with self-service computer networking, storage, and operating systems through virtualized environments. Customers are responsible for managing their own operating system, data, and applications. An example of this includes Amazon Web Services, AWS, Microsoft Azure, and Rackspace. Now that we've learned about the different cloud computing service models, let's talk about the ones that are useful for accounting. Remember that some cloud solutions can be a combination of multiple models. However, for accounting, software as a solution model is usually used. And in this type of a model, the cloud provider manages both the software and the underlying infrastructure, including storing the customer's data. So both the software and the data that is produced from the software is stored in the cloud. And the advantage of software as a service include users have access to information anywhere at any time and on any device. All you need to do is log in and you're able to retrieve your company's information. It doesn't require the maintenance costs and time of owning hardware and software because everything is managed by the cloud. It reduces the need of capital expenditures and software cost. As we talked in previous chapters, it is expensive to build the system and have servers in-house, and it offers more flexibility and scalability to meet changing conditions. So especially if you're a startup business that's growing exponentially, it's much more easier to handle an increase and growth with a cloud solution versus in-house solutions, because servers can only process and store a certain amount of information. So then you're looking at purchasing another server if you're growing quickly, whereas with the cloud solution, they have the items available. You just have to pay extra for extra storage and processing power. Although there are many benefits of using the software as service cloud model, as with everything in life, there are risks. So now let's discuss those risks. One of the risks potentially is reliability. If the customer loses internet connectivity, then it cannot use the system because the system cannot be used offline. So there's a heavy reliance on a stable internet service. The system will fail if the provider is unreliable in providing the software, monitoring and managing the software, and delivering a secure environment. So you not only need a stable internet connection, but you also need a good and reliable provider who's constantly updating and fixing the software, and they build a software package that is stable and free of bugs. Another potential issue is privacy. If there is a breach of privacy, customers' business is at risk of litigation and loss of reputation if the provider does not take steps to make data privacy a priority and delivering a secure environment. So you have to make sure that the right infrastructure is in place. So if you are collecting customer data or vendor data, any third-party data, that it is secure, or else you may face litigation because your customers and third parties are relying on you to keep their data secure and not the cloud provider. Another issue is security. The customer system and data may be accessed and used in malicious attacks if the provider does not take necessary steps to make data security a priority, and this could result in financial losses. So there are a lot of hackers. We hear a lot of information about ransom threats and organizations and hackers keeping businesses under surveillance and accessing their data and then holding their data for ransom. So it is something that is important to look at, and how strong is the security of the software as service provider. Now let's talk about how startups and small businesses use technology. Many startups just begin with a laptop and some basic software for their employees. This makes them the perfect candidates for purchasing third-party vendor software or using the software as a service cloud model, because they don't have the financial resources or the capital for the high cost of establishing an IT infrastructure. Software used by small businesses include payment processing, and this can be done by Square, GoPayment, SumUp, or Clover. My son recently participated in a craft fair, and I purchased him a little Square machine so that he could have customers pay debit or credit. So it's very easy to do. I think I paid $100 for the Square. So that provides businesses with a lot of flexibility. Data processing can be done in Excel, so you can do all your accounting transactions in Excel. Data storage can be done in Access, so we're looking at a Microsoft Office suite. Internet of Things can be used, and the group that's going to be doing Internet of Things, going to teach us that these are sensors and machines that are connected to everyday devices to collect data and leverage decision making. And there are many small accounting softwares that small businesses can use, and these include QuickBooks, Xero, Sage Intacct, NetSuite, etc., etc. As we talked about in previous classes, we as accountants are responsible to ensure that there is a secure controls environment that alleviates various risks. So some of the considerations for small businesses when thinking about IT include segregation of duties and ensuring that segregation of duties is implemented in high-risk areas. And if it can't be, then you can also look at augmenting it with supervisor approvals. So if you have just a few employees, you can't assign tasks to multiple employees. For example, if you have an accounting department that consists of 3 people, it's hard to make sure that there's segregation of duties, but what you can do is make sure that for the tasks that can't be divided and have only one individual performing them, that there is some kind of supervisor sign off, so there's not one person accountable for everything. Companies also need to think about physical access. When companies allow employees to bring their own devices to work, control should be implemented that data must not be saved. That data is saved on the company's secure network and not the personal hard drive. You don't want to have employees saving confidential information onto their own computers because you don't know how secure it is. So it's always important to have a login interface that employees access when they're at work, and things are saved on a shared drive. And as we talked about, the software as a service cloud providers allow access to that. So you save things in the cloud. And then you also have to think about logical access, and employees should be required to use strong usernames and passwords to allow them access, and making sure that only certain users that need certain areas are allowed to access them versus giving all employees access to the entire company IT system. So there should be different users that are assigned different privileges based on the different roles and functions that they perform. We started off with small companies. Now we're moving on towards growing companies. So as organizations grow, their technology needs change, and they're able to explore different options to fit their needs. And I think you know this from previous strategy classes, but organizations can grow 2 ways. One is organic growth that occurs when the company uses its own resources and business processes to increase sales, customers, and market share. So they might, go to different areas or introduce a new product line. The other type of growth is acquisition-based growth. So they can either merge with another company or acquire a smaller company, and then they need to integrate their infrastructure together. And this is quite complicated. I went through a acquisition process when I was working at Vale. Vale used to be called Inco in Canada. It was a Canadian mining company that got bought out by a big Brazilian company. So I personally went through an IT infrastructure acquisition merger, and it was very difficult. We ran our own systems for a while, and then eventually I went through a project where we installed SAP, which is a enterprise resource planning software throughout the whole organization so that the 2 companies could be linked. And when you have 2 systems running, you have a lot of reconciliation and a lot of manual work to make sure that the financial statements work out. So just for definition's sake, a merger is a combination of two separate companies into one legal entity, and acquisition is when one company purchases all or a majority of the company's shares. As I mentioned in the last slide, once two companies join together, you need some kind of system integration. And system integration is basically the process of joining different systems or subsystems into one larger systems and ensuring that they function as one cohesive unit. And there are different strategies that organizations can utilize to accomplish this. One is called the lift and shift and integrate. So basically what happens in this scenario, it's what I kind of described occurred when I was working at Vale. The acquiring company moves the acquired systems, physically placing the system servers in the data center and maintaining the existing systems as they are. Users have access to all the systems simultaneously. After the acquisition is complete, systems are reviewed and the company determines when full integration is necessary. So in our case, we were running those two systems for 2 years, and after 2 years, we started building that SAP system. The other option is immediate integration. So basically what occurs with this strategy, the company immediately integrates systems by converting existing data in the systems to be retired and migrating them into the new system. So you just shut the old system off and you turn on the new system. The problem with that is if there's different processes and procedures, there could be risks involved. So there's different ways to configure systems, and there's obviously benefits and disadvantages of each. And the 3 ways that organizations can configure their systems include having centralized systems, decentralized systems, or distributed systems. In centralized systems, all users are connected to one central location, and this is where the server is, or a cluster of servers, and all authorized users access the system from that point. And all of the network's main business processing occurs at that point, and business information is stored in that one place. So you have one place where everything happens in a centralized system. In decentralized systems, on the other hand, you have multiple locations that each maintain a copy of the data needed for its connected systems. And in a decentralized network, there are multiple access points for users, but not all users. So for example, if I have an international company, I might have one decentralized system operating in North America, another one in South America, another one in Asia, Europe, Africa, so on and so forth. And then the third option is distributed systems. And in these types of systems, all users and systems are directly connected to one another across a network, and the processing and databases are distributed among the server business locations. So everyone's connected, but there are multiple servers in multiple locations. So it kind of is a mix. If you were thinking about a continuum, you have centralized systems on one side, decentralized systems on the other side, and the distributed systems are right in the middle. So let's look at centralized systems and their advantages and disadvantages. The advantages of a centralized system is that it's easy to set up. There is better security of the central location, as there is only one access point to protect versus multiple points. There is consistency in processing because everything happens in one location. And the cost is lower as there is only one location to maintain versus multiple. The disadvantages are that the risk of a business disruption is greater because the disruption impacts the whole system versus a portion. So if something goes down, everything goes down. A single system may experience transaction bottlenecks if processing traffic is high because only one system is performing all the processing. So for example, if you have a business that is looking at seasonality, whether it's time of day, day of the week, month, etc., you might have bottlenecks where the system needs to be scaled up because there's a bottleneck. And then users in other locations may experience lag time for data access because of network and remote complications. So the further you are from the access point, there's a chance that you might have some kind of lag when you're logging in. Now let's look at the advantages and disadvantages of decentralized systems. The advantage is that with an increase in location processing and storing their own data, the processing power and storage needed at the central site is reduced because you have alternate sites. There is high responsiveness from the decentralized system at remote locations, so you're not having this kind of lag time we talked about with centralized systems. Processing bottlenecks will be reduced because employees aren't competing for processing power. And then if one system fails, the others can still process transactions, so you're reducing risk. On the other hand, when you think about disadvantages, there's increased security risk as more systems must be protected and monitored. And then the cost of installing and maintaining multiple systems at different locations is obviously higher because you have more. Now let's look at our last system, which is the distributive system configuration. When it comes to advantages, one is that there's increased communication among users because they're all connected together on this distributed system. Real-time transaction details are more readily available because you have this interlinking. And then the access and processing speed are faster because the processing workload is spread across the system. There might be some reduction or elimination of central processing sites because you have your hardware spread across. There might be a better chance for growth and scalability because you have these teeny tiny hardware servers and everywhere, so it is easier to buy an additional one versus thinking about how big of a server will we need. If there is a failure at one site, it's not damaging because the network can accommodate additional processing. So because everyone is connected, even if one site or server goes down, you can rely on the other servers. This is in direct contrast to a centralized system where because you only have one server, if it goes down, the whole company basically shuts down. In terms of disadvantages, this is the most expensive option because it involves high maintenance costs because you're maintaining all these different locations. And sometimes it is difficult to implement because it is very complex. So you're trying to figure out how do I link all these sites together. Here's a nice table just summarizing all the options. When it comes to the systems, we have the centralized, decentralized, and distributed. And here are some criteria that you can look at them based on. Probability of business disruption, maintenance costs, scalability of network, and security vulnerability. When it comes to centralized system, because everything's operating on one server, the probability of business disruption is high. With a decentralized, it's medium, because although one location goes down, the other locations continue working as status quo. And then with distributive, business disruption probability is very low because the other servers pick up the slack and the work from the site that goes down. When it comes to maintenance costs, centralized have the lowest maintenance cost, decentralized have medium, distributed have high. In terms of scalability, it's the lowest with a centralized system, it's medium with a decentralized system, and the ability to scale up with distributed is the highest. Then when it comes to security vulnerabilities, they're the lowest in terms of centralized system because you have this one access point. Decentralized, you have medium vulnerability when it comes to security, and distributed you have high because you have multiple access points. And then if people do breach the security measures and access the system, they can get the data and information for the entire organization. Now let's talk about enterprise resource planning systems that are usually utilized by large organizations. And what an ERP system does is it integrates multiple systems into a single cohesive communication systems. The benefits of ERPs are that they improve data transparency and quality, as all the business data resides in a single system, making it accessible to authorized users who need it to perform their job functions. And this improves data quality because the data is only stored once in a central location. So you don't have multiple systems that there might be errors and you're constantly reconciling everything centralized. There's future cost savings for an organization when they implement an ERP, because the long-term costs of operating the system are reduced because you own one system versus multiple systems. However, the initial implementation and customization of the system is very expensive. As I mentioned, I went through an ERP system implementation project and it was very long and time consuming because you need to understand the entire company and all of its processes and map them out and try to figure how to integrate them all together. Another benefit is increased business efficiency because one system simplifies the collection, analysis, and reporting of data, and it improves business decisions. There are also quality improvements because it allows for better benchmarking because you're continuously collecting, analyzing and reporting business data. There are reporting modules that you can have standardized reports and different dashboards that management can look at. And then it can automate business processes because everything can be standardized and automated within the system. Now that we understand what an ERP system looks like, let's learn more about its components. So an ERP module is a function of the ERP system, and businesses have the choice of choosing which ERP modules that they utilize. Standard systems like SAP and Oracle have a lot of modules available, and they can be customized to the business. And an ERP feature is something that corresponds to the business process, and it has specific capabilities within the systems module. The most common ERP modules that you will see are a financial module, which is something that you as an accountant will be working with. And this just captures all the accounting data and generates financial documents, both internal management reporting and external financial statements. You have supply chain modules that manage the entire supply chain from purchasing of raw materials and supplies through to final inventory management. They can also manage logistics, and they can manage supplier relationships. More and more businesses are integrating their ERPs with suppliers, so they are constantly connected and have access to the data. There's production modules that are used to manage production activities, including machine operation and scheduling. So these modules are designed to, figure out which products should be produced when, and obviously they'll be integrated with the supply chain inventory module so that decisions are made in a cohesive fashion. There's customer relationship modules that collect customer information. We have sales management modules that track orders received from customers through the shipment of goods. So you have the order requisitions there and order fulfillment within this module. And then you have human resources module that manage employee records, including time tracking, payments, etc. Here's a visual example of an ERP system with the links to the various modules. We have our customer relationship module that looks at marketing management, customer relationship management. We have our sales module that looks at shipment of products, quotation of prices, point of sale systems, receipt systems, and order systems. We have our financial module that looks at the various types of accounting, budgeting, accounts payable, receivable, etc. We have our human resource module that looks at employee time tracking, training and development, recruitment and onboarding, and talent management. We have our production module that looks at product costing, raw material management, bill management, etc. So as you can see, this one company has one system with various modules, and employees from different areas would have access to the specific modules that they need. Let's talk about implementing an ERP system. As I mentioned, I was on an ERP implementation team, and it is a very complex process. So let's discuss some of the key business considerations of adopting an ERP system. You have to ensure that management will champion the product and intervene if there's any issues. You need to ensure that you choose the correct vendor that has a solid reputation within the industry. You need to choose a solution that meets the company's needs with as little customization as possible, because customization is very expensive and it can be time consuming. There needs to be sufficient time and resources allocated to post-implementation training of employees, so employees know how to utilize the system, use it for their jobs, and actually achieve some of the benefits we talked about in the previous slide. And then you have to embed internal controls during implementation to ensure you have a cohesive and strong control environment. So there are different ERP solutions that organizations can choose from, and most vendors offer different types of solutions for companies to choose. And the three most common types, you have an out-of-the-box ERP system, and this system is just pre-configured to work one way, and it can be immediately implemented, and customers are expected to adjust their business processes to match the system. So you can't adjust the system to match your processes, you're changing your processes. So these types of ERP solutions are great for businesses that are starting out and don't have well-established processes, because they can establish the process based on the system. We have configurable ERP systems that have some add-ins and features that can be customized to a customer's needs. And then we have customizable ERP systems, and these systems have fully customizable features and are created based on the customer's processes. So these ones have the most flexibility. Some costs that organizations need to keep in mind when deciding on an ERP are the licensing fees that they have to pay the provider, and these usually are, an annual expense. You have to think about the cost of customization. How much is this going to cost you? The hardware required. If you need external consultants to implement this project, or can you use your own individuals? Most organizations hire consultants just because it's such an undertaking. So you'll either be hiring your own staff to do this, or you can hire specialized consultants that have experience with ERP. And then there's a huge cost of training employees on the new system and ensuring that they are happy and agree to use that system. Okay, that is it for this chapter. Please let me know if you have any questions and have a great day.